Welcome to our exploration of water systems and leak detection within building management systems, or BMS. In modern buildings, water systems are essential for everything from daily comfort to critical safety. But with water comes the risk of leaks, which can cause significant damage and downtime. That's why integrating water management and leak detection into your BMS is more important than ever. In this video, we'll break down the types of water systems found in buildings, how BMS monitors them, and the vital role of leak detection. Let's dive in and discover how smart systems keep our buildings safe and efficient. Water systems are the lifeblood of any building, supporting everything from drinking water to climate control. Domestic water supply keeps restrooms and kitchens running, while chilled and hot water loops are crucial for HVAC systems. Without reliable water systems, daily operations would grind to a halt. But these networks are also vulnerable. Leaks can disrupt services, damage assets, and even pose safety risks. That's why understanding and managing water systems is a top priority for facility teams. In the next scene, we'll look at the different types of water systems you'll find in a typical building. Buildings use a variety of water systems, each serving a unique purpose. Domestic water supply delivers drinking water and supports kitchens and restrooms. Chilled water loops cool the building through HVAC systems, while hot water systems provide heating or hot tap water. Condensate drainage removes water from air handling units and other HVAC equipment. Irrigation systems keep landscaping green, and cooling towers help large HVAC systems reject heat. Finally, fire water systems are critical for safety, powering sprinklers and hydrants. Each system has its own monitoring and maintenance needs, making BMS integration vital. To keep water systems running smoothly, BMS uses a range of sensors and controls. Inlet and outlet temperature sensors monitor system performance, while flow sensors and water meters track usage and detect anomalies. Differential pressure sensors help spot blockages or filter issues. Pump status and variable frequency drive, VFD, controls ensure efficient operation. Tank level sensors prevent overflows or shortages, and make-up or bleed-off valve controls in cooling towers maintain water quality. By collecting and analyzing this data, BMS helps facility teams respond quickly to issues and optimize system performance. Water leaks can strike anywhere, but they're especially dangerous in critical areas like data centers, electrical rooms, and under raised floors. Even a small leak can cause major equipment damage, downtime, and safety hazards. That's why leak detection is a must-have in modern buildings. By integrating leak detection with BMS, facility teams can spot problems early, respond quickly, and prevent costly disasters. Next, we'll explore the components that make up a reliable leak detection system. A robust leak detection system includes several key components. Leak detection cables sense moisture along their entire length, making them ideal for covering large or irregular areas. Point sensors are used for specific locations, like under a piece of equipment. The leak detection panel acts as the brain, interfacing sensors with a BMS, often using BACnet or Modbus for communication. Alarm outputs, such as dry contacts or digital signals, alert the BMS when a leak is detected. Together, these components create a comprehensive safety net for your building's most vulnerable spaces. Let's take a closer look at how leak detection systems operate. When moisture is sensed by a cable or point sensor, the detection panel processes the signal and sends an alert to the BMS. This can trigger alarms on front-end graphics, send SMS or email notifications to facility teams, and even initiate automatic shutdowns of equipment in affected zones. Trend logs record when leaks occur and when they're resolved, helping teams analyze patterns and improve prevention strategies. This seamless integration ensures that no leak goes unnoticed and responses are swift and effective. The real power of leak detection comes from its integration with BMS. When a leak is detected, the BMS can display alarms on user interfaces, log events for future analysis, and notify the right personnel instantly. In some cases, the system can even automate protective actions, like shutting down pumps or isolating affected zones. This level of automation minimizes damage, reduces downtime, and keeps building occupants safe. By connecting leak detection to the broader BMS, facility teams gain a powerful tool for proactive maintenance and risk management. Certain areas in buildings are especially vulnerable to water leaks and require extra protection. Data centers and network rooms house sensitive electronics that can be destroyed by even a small amount of water. Electrical and UPS rooms, as well as spaces under raised floors or ceilings, are also high-risk zones. HVAC mechanical rooms, especially those below air handling units or pumps, are common leak sites. Even washrooms and pantries located above critical equipment need monitoring. By focusing leak detection efforts on these areas, facility teams can prevent the most costly and disruptive incidents. Let's look at some real-world examples of how BMS and leak detection work together. In a chilled water system, if a leak is detected, the BMS can immediately alert the operator and automatically shut down the chilled water pump in the affected zone, preventing further damage. For water tanks, ultrasonic sensors monitor levels, and the BMS controls refill valves as needed. If levels fall too low or rise too high for a set period, alarms are triggered, ensuring water availability and system safety. These automated responses save time, reduce risk, and keep building operations running smoothly. To maximize the reliability of leak detection, follow these best practices. Use supervised leak detection panels for higher reliability. They can detect faults in the detection circuit itself. Regularly test leak sensors during scheduled maintenance to ensure they're working properly. Avoid placing control panels or IT equipment directly below water lines to reduce risk. In critical areas, use loop-type leak sensing cables for full coverage. These steps help ensure that your leak detection system is always ready to protect your building and its occupants. In summary, water systems are essential to building operations, but they come with risks that can't be ignored. Integrating water system monitoring and leak detection into your BMS enhances reliability, efficiency, and safety. Leak detection systems act as a critical layer of protection, reducing the risk of damage and enabling preventive maintenance. By following best practices and leveraging automation, facility teams can ensure that their buildings remain safe, efficient, and resilient. Thanks for joining us. Stay proactive and keep your building protected.